Hi again, this is Nick Marchuk, and this is the third video in my series from 2022 on making a printed circuit board in Eagle. So in the first video we made a library of components. In the second video we used those components to make a schematic file, and now in the third video we're going to draw a printed circuit board based on the schematic. So on the left, this is a board that I've already designed, basically the first run of what we're doing right now, and I've made the schematic to match, and now we're going to try to draw this board. Usually the second time comes out a little nicer, so we'll see how that goes. The only requirement that I have for this board is that I've got these header pins on the left and the right. Those need to line up at these specific positions, and I would like the board to have this specific size so that I can fit a shield onto this later that is going to have some other goodies like another microcontroller and a camera and some Bluetooth and stuff like that. So something we can take from this design though, we're going to put the pick in the middle because the pick is kind of the heart and it has a lot of connections that fan out from either side. Things that we need to touch or see should go at the edges, because if there's a board on top of this board, we won't have access to them later. So we'll put our buttons towards the sides and the LEDs. Then we've got header pins for the snap and header pins for the USB to UART. We'll put those on the side, and we'll actually solder right angle header pins in. So the snap will come in from the side, not from the top, and the USB to UART will come in from the side, not from the top. And then here's our slide switch and our battery connector for power and the voltage regulator down here. So we're not really required to put any of those in specific places, so maybe I'll play around with that as we go. Okay, so in the last step, I took our schematic and clicked the SCH to BRD generator, and we've ended up with our board. Now I can always go back and make changes, but I need to make sure that my BRD file and my SCH file are always open, because if I make a change in one, it has to propagate through both. So if I try to close this right now, back in my schematic, I get a little banner warning at the top that says, uh-oh, you've now unlinked these two files because they're not open at the same time. So try to keep them open at the same time. The first thing I want to do is make the printed circuit board the size that I'll be ordering, which I've pre-decided as 50 by 50 millimeters, just based on price. So I'm going to switch quickly to the millimeter grid size, and I'll do an info on my board, and I'll change it to be 50 by 50, which isn't exactly tight, but actually the price for 100 by 100 is about the same. I just don't really want to make a board that's 4 inches by 4 inches. It's pretty big. Okay, so I've got a 50 by 50 millimeter board, but I do prefer to work in inches, or actually in mils, thousandths of an inch. So I'll switch back to that. And now the job is to take all these parts and stuff them into this tiny board and make the connections. We can see the connections right now are these yellow lines, so it's telling us which pins based on the schematic should be hooked up to each other. So the goal is to take the parts, put them on the board, and then minimize the number of crosses of those yellow lines to make the connections easier. And the last thing to notice is that this is the free version of Eagle. So if you can't have an infinitely sized board in here. If I grab one of my parts and I try to move it outside of the maximum size that the free version of Eagle lets you do, it'll just give me an error at some point that says, you can't do that. Yeah, well, I don't know. Eventually it'll do that. It's just not letting me drop it wherever I want. Okay, well, maybe we'll see that later. Okay, so I'm going to take the pick, and I'm going to orient it face up, so the divot at the top, I'll put that. It's kind of the middle of the board. If I want, I could even make sure it's the exact middle of the board. Doesn't particularly matter, I guess. Also, it's not really 2 inch by 2 inch, but whatever. Okay, so the pick's in the middle. And other things. So this display, I kind of want it to hang out off the side of the board so I can see it. Because if I leave it here, for instance, first of all, it's probably going to hit the pick. And then second, when we put the shield on top, I won't be able to see it anymore. So I'm going to put it over here and try to hold it so that my labels don't fall off the side of the edge. Okay. What else should I put in early on? Let's see, the snap is how we program the pick, and that needs to be near an edge. Notice that Eagle's kind of smart here. It's saying you can't put this too close to the edge of the board because there are some rules defined somewhere that say the manufacturing tolerances, and if you drill these holes too close to the edge of the board, they might crack the board. So I don't want it to be that far away. I'm going to hold the Alt key so I can get a finer resolution on my grid and slowly back it off until it's the closest I can get to the edge of the board. And I'll take my USB to UART, and so I can kind of see there's two main connections between the PIC and the USB to UART. I know I can't put it on the left here because that would be kind of convenient. Put it right here because I have other connectors that need to go there. So probably want to put it over here. And again, I'll use my Alt key to get as close to the edge as possible without generating that little warning. Now, physically, I'm holding my my USB to UART converter in my hand, and I'm noticing that when the chip side is up, the ground is on the right, so I kind of like this orientation. Okay. What else do we want to stick in here? So we've got some connectors that I know have to be in certain position. So for instance, the A0 pin has to be at 0.1 by 1.45. So let me put that in there. I can remember where I put the center of my device. And the center pin for some reason. That'll make it a little bit more annoying to place, but it's roughly going to be around there. Center pin. So where did I put B6? B6 is somewhere in the middle. Okay. Then I need to find my B15. That's going to be up there somewhere. And then this somewhere around there. Okay, I'll move my voltage regulator maybe somewhere over here. Based on how I did it in my previous design. And my slide switch. I'll eventually try to stick it in here somewhere. These are all rough placements. I need to get my battery down there too. That's going to be tricky. My capacitors are supposed to go very close to the PIC. So let's see, C1 in the top right, C2 in the bottom left. So you can see how we know that the top right pin of the PIC is 3.3 volts, and the top pin of this capacitor is 3.3 volts, but it's not drawing those yellow lines there. So once I drop it and I hit the rat's nest button, it'll do a shortest calculation to show, okay, now those pins are definitely supposed to be touching. C2, go down here, do a rat's nest, and I can decide the orientation later. C3, which had to go to VCAP. Okay, got these extra holes for going to SDA and SCL, power and ground. Put those close to where they should go. My previous design, I put the extra power pins under the regulator. Probably not a good idea because once I solder the regulator on, I won't have access to those pins anymore, so I might want to put them somewhere else, but I'll put them there for now. Okay, finally I've got a reset button that can go somewhere, and a user button, and I've got power LED, and a user LED, and then a bunch of resistors. I don't really know what the orientation should be just yet. Let's throw them on there. Okay, so almost success. I've got all of my parts on my board, so it should be possible to route them. Now maybe a little bit more organization. First, let's figure out how to get my header pins in the right position. So the downside of putting the center pin as the origin for this connector instead of the top pin is that I need to make sure the top pin's at a certain location, but it's 0.1 lower than it's supposed to be. 0.2. So A0 is supposed to be at 0.1 by 1.45. So 0.1, that's the correct X. For 5 would mean 2 above this, so this should be 250. Is there really that much of a gap? Yeah, that's a pretty big gap. Okay, and then B0 was B15 was supposed to be at 1.85 by 1.45. X would be 185. Okay, so according to my previous drawing, those header pins are now in the right spot and they should be locked in position. And I should be able to do an info on this and say locked, and that would mean that it can no longer be moved by accident. Whereas all my other parts, I could still move them if I really want to, including the pick, but these are the ones that I don't want to accidentally nudge. And then, so notice their silkscreen layers, they say 5 and U stuff. I don't really care about that. I'm going to delete those. Oh, apparently not when it's locked. That's too bad. Z. Okay, maybe I won't lock it. I'll just be careful not to move them. Live dangerously. Okay. What else doesn't need labels? I don't really care that this is R1, R3. I just care that they have their values. So I'm going to get rid of their names, keep their values. And this LED, I'll refer back to figure out that it's the user LED, and that should be green. I just don't want to waste space for its names and stuff, but I'll keep the user label and the reset label. Okay, and we're going to, I don't care that it's the snap, I don't care that the value, actually, no, I do care about the value of the capacitor, but I don't want to know the name. It's all about saving space. That's going to trash. Display username, the UR username, slide switch. Get rid of the names of these connectors. I'll add labels later. Okay, that cleaned it up a lot. See what else we can do with these components to get them out of the way. So by holding the Alt key, I can move this button around, trying to find the position where it's kind of like as far to the right as it could be. And maybe I can find a way to get this label in there. Not really. I'll just stick it here. Nice. This didn't have to route around that. Maybe we'll put the buttons on the outsides and we'll put the LEDs on the insides. Okay, so some of these yellow lines I can't really uncrisscross just the way that they've been designed, but we've tried to minimize it as much as I can. Last thing we've got is to try to find a place for this USB to UART connector. See if we can nudge it over to the slide switch. So this right side of the slide switch is the back of it, so I can't really let it touch anything. There needs to be just enough space. See, we need to get this out of the way. Don't want it to hit the connectors. Okay, so I've got placement's in a pretty good spot, I think. The next step is to start to route things. So I could use this eyeball tool, the show tool, to click on a wire and it'll tell me, down here it says the name, this is the B15 trace, and those are the 2 pins that need to be connected. And most of them are point to point, but the complicated ones would be like this. Here's the ground connection. So pretty much everything has to get connected to ground somehow. It'd be really nice if those could be automatically connected. And one way to do that is with a ground plane. So the first thing I'll do is I'll connect all the grounds to each other using the polygon tool. So I'll grab the polygon, and I'll draw this polygon on the bottom layer of copper. And I'll just draw a big wire all the way around my board. Double click to end. And I'm going to call it ground. And it doesn't draw itself until I hit the rat's nest button. So that's one of the things we're constantly going to be doing is every time you draw a new trace, probably hit the rat's nest button so that things like update. So when we zoom in on the polygon, anything that is connected to ground has been drawn with blue wires. Anything that is not has a big circle around it, so it's not connected to ground. The gap between that is called the isolate parameter. So I'll go into the info and I will find the edge of that thing, and the isolate is how far away it should stay from things that are not ground, and I like to give that a pretty big gap, so I'll give it a 16th thou gap. So now things that are not ground are pretty far away from the ground plane, so they're not accidentally short. Other parameters that we have available would be, for instance, the thermal option. If I uncheck the thermal option and say OK, see how the ground is now fully encapsulated by the ground plane. That's now very difficult to solder because when you have to solder this ground pin connection, it's really thermally connected to this ground plane. So you have to heat up this ground plane in order to solder that pin. It makes it pretty difficult. So we leave that thermal option on so that it's easier to solder, even though the electrical connection to ground isn't as good as it could be, but it makes it a lot easier to solder. Okay, so now all the ground connections have been made for us. If I go back to the show and I select ground, will it let me? Yeah, all of the ground pins automatically connected, so we don't have to worry about that. So now you get to choose what do you want to connect first, because some of the connections will make other connections more difficult to make. And we probably want to stick to some kind of consensus of being like, okay, we've got a lot of side-to-side connections here. Let's make all the left ones. We have to pick whether they should they be in the top copper or the bottom copper. Not sure if it makes sense one way or the other, but we should be consistent. So why don't we make everything that goes left to right? Let's start on the top layer. Let's see how it goes. So I'm going to be on the top layer, and I'm going to use the route air wire, which will draw a trace. And I'm going to make my traces 16 thou wide so they can handle lots of current. And I'll just start doing the easy ones. So for instance, the cap pin goes to the 10 microfarad capacitor, and that 3.3 goes to there, and this 3.3 goes to there. Notice that this ground is also going to that ground, but through the ground plane. Don't have to make that connection. Okay, so that wasn't so bad. What else we have? Let's do an eyeball. There's a complicated one. Let's not do that yet. But this guy goes here. So technically, diagonals shouldn't be possible. I should go left to right in the top plane, and then switch to the bottom plane. So to do that, I could go here, and then I would go to the bottom, and I would drop this via, and then I would go here. And then I would do rat's nest to see what it looks like. I'm going to say that's not necessary in this one. I'll let the diagonal happen, but we don't want to do too many diagonals. So I go on the top plane, and what kind of cheat to make that connection. And maybe I'll do the same over here. So one thing you'll notice is I'm not letting there be any right angles in these connections. Right angles are generally not good on a PCB because high frequency signals kind of bounce off of right angles. So we'll do 45-degree angles. Okay, so here's a good example of when things get a little tricky. B15 needs to go straight across, but this 3.3 needs to go across there. So if they're going to cross each other, I either need to nudge them down or make sure they don't touch. So I'll try nudge first. So we're going to make this 3.3 volt connection using angles. And then we'll do this B15, scooching around the edge of these connections so they don't accidentally touch. And then we'll kind of scooch this one around here so that by the time we get to here, we don't need to do any more scooching. And sometimes I could go back and look at this and be like, oh, well, maybe I should just divide that in half. Kind of keep a constant distance between them. There's probably math behind that kind of stuff, but I like to go with symmetry. Okay. Keep routing wires. Okay, here's some good crisscrosses. So these guys need to end up down here, but these needs to end up there. So what we want to do is go across, and at some point switch to going down. Switch back to the top layer, finish them off, and use the rat's nest to show that that's no longer a ground. Start at the top layer, switch to the bottom, switch back to the top, and finish the connections. Now, if I did it right, I could probably figure out how to keep the other ones totally on the top layer. For instance, could I... Oh, P6 is going somewhere else. Sneak this through here. But the tricky one's going to be whatever this guy is, this VIN connection. I'll have to sneak through somewhere else too. We'll come back to figure out that later. Okay. Finish this guy off as long as we're here. So if I want to be consistent with my left to right and up to down, this is mostly an up to down. This should probably be at the bottom. Easy to forget your own methods. Okay, now MCLR needs to go left to right, so that should be in the top. These guys need to sneak through here, so this line's probably not going to work, so I'm going to uproute that. We'll redo that one later. Okay, so MCLR needs to go that way. I'm just going to leave it dangling here for a second. Because these guys, maybe they should be blue. So I'll switch you to bottom. And see if we can continue this. How about that? Okay. And then maybe we can get these guys to go this way, but we'll go underneath. Okay. And now we're going to have the trouble of getting this 3.3 guy there. Because I've made a pretty nice wall by having that blue and that red right here. Can't really go over that with blue or red. Deal with that later, I guess. Okay, let's start on this side of the chip. This one's pretty sneaky. Okay, so here's our communication wires. So sneak those through there eventually. Let's go look at those power things for a second. So from this battery, we're going to go to the switch and back to the regulator. Those could be some high current lines, so we'd like these maybe to be a little thicker. So I'm going to bump these wires up to 24 thou. So the battery connects to this part of the slide switch. And VN is able to power the regulator. Then we have to get 5 volts out of the USB to UART connection. Must be over here somewhere. And I wonder if this should go on the bottom, because later on we need to get those guys through here. But our top to bottom is blue, so probably should be red. It's a little too high. So perhaps we'll go over here in red, and then we'll switch over to blue to get up to here. Switch back to red. Finish it off. Oops, that guy's gonna get in the way. So we'd better follow our rules over here. Up route this guy. Switch back to the top. There we go. Okay, let's keep doing power stuff, maybe. And 3.3 volts. So this is actually where the 3.3 volts comes out of the regulator to get to the rest of the circuit. So let's have it kind of. Yikes. Okay, we're just gonna start on whatever. So we're gonna be at 16 thou. 3.3 volts come over here, switch to the bottom really fast. Perhaps come up to here to snake its way to there. Okay, we've got another VN. Now for this VN, it'd be tempting to go blue this way, but I don't want to cut off those two grounds. So we'll only go that far in blue. Okay. Getting there. Let's look at our communication pins. That's going to be kind of complicated. This one and this one, and they crisscross each other, of course. So let's sneak it down blue. Maybe between here. So we'll start on the top so they can crisscross each other. We'll switch to the bottom. Sneak between these two pins. Excuse me. Okay. So the RX is there. It's starting to slice up our ground plane a little, but not too bad. That a little less pointy. Okay, so the disadvantage of having these long blue guys cut across our plane is that this ground is now pretty far from this ground. It's got to go kind of all the way around there. So we don't want to cut up our ground plane too much if we don't have to. Kind of inevitable, though. Okay. So what else? We've got to get this B5 over here. Here. So that certainly makes the connection, but it does cut a big hole in our ground. I think probably it's best that we don't do that. Instead, we have this one follow some red convention. Okay, how are we doing? This guy over. That guy over. Okay, we still gotta get these two guys way up there. Might help to move this guy a little. Something like that. I don't know where this is going yet, but I'll just bring it up here. Bunch more crisscrosses happening. See, that's supposed to go to the switch. Now it's supposed to go to the LED. I don't really like that. This 3.3 needs to make it up there. Oh, again, I had my thing plugged in all the time. Okay. Okay, it seems I've gotten a lot of stuff out of the way there. The A1 didn't have to go around that way. Go around this way instead. I'll give a 0 some more space. Okay, broke that up a little bit. What connections are we still missing? Some 3.3 volt? Yeah, so we've kind of isolated that 3.3. Still hasn't made it over from this side. So we could bring it up but around here and then back down. We can somehow get this over here. That looks hard. So it better come up here, connect to here, and then somehow get that down there. So how can we get this guy through here? We'll break that up. And we'll have it go on top. We like that. Okay, now we need to get MCLR over. Have this go blue. Oh, okay, how about that? Very sneaky. Okay, and this will just have to be blue the whole time. So I think I've got all my electrical connections. One step that we can do is we can do a rule check. And a rule check is based on manufacturer requirements. So that is these DRC. And we have to load a DRC file. And this has come from, in this case, we're using one from SparkFun. Say check. And what doesn't it like? Let's see. It doesn't like the size of my vias. I think they have a conservative size for their via, so I'm going to say clear all. But what that would also check to see is do any of these wires come too close to any other wires, things like that. But Eagle didn't really let us do that anyway, so I think we're good. Okay, what else can we do? We can say turn off this top layer just so it's not clogging our field of view. And now let's just look at all of our blue wires. See how well we did our convention of up and down blue wires. Pretty good, I think. And I'm just looking around for anything that could be straightened or simplified. For instance, going between here, it doesn't look like it was really necessary, but I think we could leave it like that. If this pin, this bottom right pin, had been ground, it would not have been able to touch ground anymore, so we wouldn't have had to loop on either side, but it's not ground, so we don't have to worry about that. Yeah, I'm pretty happy with that. So we turn red back on. This time we'll turn blue off. Probably some straightening we could do around here. Also not anything too obvious. This guy. Okay, so the last step, or we're getting towards the last steps, we need to add some labels so we know what these pins are. So I'm going to go to the text tool and type in A0, and I'm going to put this label in T21, which is the top layer of silkscreen, and it should go near the A0 pin. And its font size of 70 might be a little big, so let me go down to 56, sure. And the ratio is kind of like how big the lines are. I'm gonna make it a little thicker, more like a bold. Do it. I think that's what it means. And I'll try to put it right in the center of that pin. And once I've got that one there, I'll copy it and bring it down to all the others, because I know they will snap to 0.1 inch spacing. That's how far apart the pins are. So that one's going to be a problem because there's a via right there. And just by looking at the markings underneath, this is going to be an A1. So functionally, this doesn't do anything, but without me having to go back and look at this document, the labels would be great. And we kind of pay for the silkscreen layer even if we don't use it, so we might as well load up on silkscreen. I don't know why I gave myself 2 ground pins here, whatever. Okay, and then we'll copy one of those, bring it over to this side. Seems to line up pretty good. Okay, so all those labels look pretty good. The only label that we're worried about is this one. Well, these two. This VN is on top of this VIA, so that V as a whole, not going to make the VN look great, but it's fine. And we'll lose that 3 on this 3v3. I'm going to leave it. I could try to move the VIAs, but it's not. Doesn't look like it's worth the effort. Okay, this 10 microfarad could probably move up here, so it doesn't hit a VIA. That 1 microfarad's good. This 1 microfarad's not in a great spot. We'll move it over here. That label's good. That label's good. That label's good. This the LEDs, I like to put a plus on the long side to remember which way to solder. So anywhere that would help us to solder, nice to add some labels. So this is the plus side of this LED. Plus side of this LED. That triangle's there to remind us how to plug in the snap. Maybe I'll put another triangle here just in case. Grab the line tool, T21. Got our RTS and ground for that guy. Slide switch, we got the plus and minus to remind us how to solder in the battery. I want some labels for our extra pins. Down's going to overlap, so we'll have to make these a little smaller. So 40. Won't go smaller than 32. It tends not to print very well. So far, I've only put silk screen on the top layer. We could also put it on the bottom because we're paying for that too. So if you really wanted to, we could, let's see, let's turn off some layers here. I can group all of those and then make a copy of them over here. Now here's a new thing. Let's group them all together again, and then there's a change button. I'll change their layer from 21 to 22, the bottom. And then I probably should mirror them, because if you're looking from the bottom, they need to be upside down. And then we'll move them right back on top of their pins. Group all oops. I wonder what those views are holes. Turn those off. There we go. Okay, so we will copy and regroup. Change their layer to 2. And then we'll mirror. And then we'll move. And then we'll turn everything back on. Okay, anything else? Functionally, not really, but it's great. Always a great idea to write your name, so you know whose board this is. I'm gonna call this ME433 2022, but you could write your name, and we'll put it on top of the bottom. So we're up here. And the last thing, which is kind of fun, which isn't required, would be let's put some kind of logo down. So what I've done is I picked out the Chicago flag. I turned it into a monochrome bitmap, so a .bmp file. And what we could do in Eagle is run a script that will turn that bitmap into one of the layers. And then we could have this logo on our board. So pick any picture you want, turn it into a bitmap, figure out what the colors are. So this text bar up here is gives us the ability to type in commands, which we haven't really done. But any command you have over here on a button, you could type in a command here to make that function work. One that's very common would be a rip up command. So if I wanted to rip up a wire, I'd grab the rip up tool and then rip up some wires. If I wanted to rip up all the wires, there's a command rip up all, which makes it very convenient to get everything out at the same time. If you had a lot of commands you wanted to run in series, you could actually write those in a text file, and then Eagle could run them, kind of like a M file in MATLAB or a Python file, and that would be called a script or a ULP. Those are the ones that come with Eagle. And so one of the ULPs, actually, there's lots of interesting ULPs like generate a bomb or generate a DXF from this board that you could then import into another CAD program, and then have this board in that file to help you make a case or something. But we're going to use the one that's import an image bitmap. So if I import a bitmap, and we get a little description here, I could go select my bitmap of my Chicago flag. And then, let's see, I want the black to turn into silkscreen on my my board. Is that right? Yeah, let's have that be white. So black, I want to end up being white. And so this image is 1200 pixels wide, and I'd like that to end up being, sure, maybe like 1.2 inches. So of 1 pixel turn into 1 mil, but you can have different scaling factors. And I'm going to have it put it into layer 200, which is definitely not a silkscreen layer, but later we'll tell Eagle to put layer 200 into the silkscreen layer for us. So we'll say, okay. And Eagle's just written a script that will run that will basically turn my stars into rectangles, lots and lots and lots of rectangles, and then it's going to draw them when I say run script. So down here, we'll start to see all those things appear. This is very inefficient because this is not like, it is vector graphics, but it's not like angle vector graphics, it's like bitmap vector graphics. So not very smart. But in this way, rather than put this in this layer, we could put this in any layer, and this is how you could do PCB art. So you would draw your art in some other art-based program and then kind of import it to Eagle. Unless you want to figure out how to do art in Eagle. Okay, so there's my flag. It took a long time to render. I'd like to move it, but it's going to be hard to move because it's on top of all this other stuff. So I'm going to turn off lots of layers so that basically I only see layer 200. Oh, probably hide layers. So when I move it, I don't want to accidentally move other stuff. Okay, so now basically I only see layer 200. I'm going to group all those lines together. I'm going to grab my move tool and just going to move it off to the side. And now I will turn all my layers back on and try to move this layer back on top of the PCB. And I'll probably try to put it on the bottom layer of my PCB so I can see it from back. So grab move. And where can I put this? It's going to get all chopped up by the pick. Maybe I put it over here. Over here? That's probably best to be over here. So anyway, this is just for fun. Okay. And now, of course, it's on top of some of my things at the bottom. So I'm going to turn off layer 200. And I'm going to try to move some of my labels over. Ooh, and something just changed my grid to being very fine. Something about importing that bitmap. Okay. Turn layer 200 back on. Maybe I'll turn off some other layers to see what that looks like. Okay, and I'll just delete the ones that are overlapping. Oops. Okay. So that's fun. At this point, I think I'm pretty done. I can turn this into Gerber files, and then we should double check what the Gerber files look like. But if you really wanted to go crazy, we've got space over here, we've got space over here. We could put more vias in there, and we could break out more pins that maybe you want. So, for instance, the B4 and A4 pins for the user button and the user LED, maybe we don't want to solder those in, and we'd rather put other components in there. So we could break out pin A4 and B4. Why don't we do that just for fun? Let's do it in a way where we don't have to change the schematic. Let me add a via, and I know a via that would fit a wire is a 40 with a 74 diameter. So that's the same size holes, all my other holes. And I'll just stick it in over here. And if I give it a name that matches A4, now it knows it's supposed to be connected. And I can go in and make the connection. And then I probably want to give myself a label that says A4. It's very small for some reason. Ooh, and the ratio is all weird. Okay, so that's just an example of how you could add more holes in. So anything that you might want more of, more powers, more grounds, 3.3s, 5 volts, VINs, pins that maybe we didn't know we needed. For instance, CTS and RTS, which we didn't do anything with. Maybe we should give them extra holes so that just in case we want to solder wires in. I don't know. That's up to you. Okay, so the last stage is to generate what we call Gerber files. Gerber files are always sent to the manufacturer. Sometimes the manufacturer will take this .brd file, but most often they don't want to deal with that. So how do we do Gerber files? We would go to the CAM processor, and we're going to use the default CAM processor. In the past, I've used SparkFuns, but it's now kind of legacy that doesn't seem to work anymore, and this one works fine. But we need to make some edits. So when we look at the CAM processor, it shows us these Gerber files. These are the actual files that will be generated. If you click on top copper, it's going to show us that the layer 1, 17, 18 all get put into this file, which makes sense. Those are all the ones that are supposed to be copper. The ones we probably want to play with would be the top and bottom silkscreen. So the top silkscreen layer, what do we want to appear in here? Let's see, it's not showing my values for my resistors because it doesn't show the T values layer. So I probably want to add T values. So right now it's showing T place and T names. I also probably want T values. Then it puts in all the values that I didn't delete. And the T names are in there, but I think I deleted all the names, so none of them appear. So the bottom silk screen, I also want to add layer 200 because that's where my big graphic is. 200. So that shows that. Anything else that I want to add? I don't think so. So those are the main changes to make to the CAM file. So I will say process job, and I have to tell it where to go. It's going to go into, actually, I like to make a new file. So I'm going to make a new folder called Gerbers. Sometimes it makes a lot of the files and doesn't put them in their own place. So in a folder called Gerbers inside of my project, hopefully it's going to make all of those files. So in my project folder, it made a folder called Gerbers, and inside of Gerbers, okay, it did make its own folder. CAM outputs, and there's the Gerber files. So we've got the bottom layer of copper, the top layer of copper. We've got the profile, which should be the outermost edge, silkscreen top and bottom, solder mask top and bottom, solder paste top and bottom. It's missing the drill file. For some reason, they put it in this drill file folder. So copy it out of there, put it into Gerber files. Now I'm going to make a zip version of this folder, and this is what we send to the manufacturer. So I'll send to zip folder, and I'll call this ME433-2022. Now we should look at this in somebody else's software to make sure that it looks right. So I'm going to go to the Seed Fusion website. So Seed is a company that will manufacture boards for us. But they have a nice little Gerber viewer. So I'll say add Gerber files. And I will, let's see, go to that zip file that I just made. Let it upload. While it's doing that, I'd like to point out those Gerbers. Usually pretty small. It's the complicated ones that have big files. So the bottom layer of copper is kind of a big file because of the complicated shape of the ground plane. And the silkscreen layers are also kind of complicated, especially the where they have like complicated stuff like the image that we made. Okay, so the Gerber's uploaded. We could click the Gerber viewer. And this isn't a great interface, but it's okay. Apparently they're kind of complicated because it's taking a while to load. Oh, apparently I crashed it. Still thinking. Maybe I'll try again. Gerber viewer. We'll try to upload again. Okay, so we go to their PCB, add Gerber. Uploading. Gerber viewer. It's not going to work. Okay, let's try Mayhew Labs. So I've got all my Gerber files. I can drag and drop them into this web interface. Even make sure that they line up. Copper, copper, the drill. That doesn't matter. Screen, paste, done. Website sometimes has problems scaling, which, yeah, it did. Okay, so suspicious. PCB. I'm not sure if anybody else will show us a render without logging in. Did not do it. Okay, maybe my computer is just a little overloaded with all the things we're doing right now. But we can normally look at those Gerber files. They would look very similar to this. And sure, we will save this cam file so I can use it again later. And that's designing PCB. So try to upload your Gerbers. Make sure it looks like this. I like to sit on this for a day or two and come back and look again. It helps to turn layers on and off. So for instance, we'll turn off some layers just to see the red, and then turn that off just to see the blue, and think about pins that you haven't used yet. Something we didn't do here was we didn't add mounting holes. So how are we going to mount this to something? I think that won't be a problem in the future. We just clip it on the sides. But sometimes you put mounting holes in here so that you can put a screw in and physically mount it. Okay, so if you're an ME433, get to the stage, upload your, I want to see your BRD, your LBR, and your SCH, and some images of these two things in your Git file, and let me know if you're going to order, and I'll take a look before you order. Okay, thanks for watching.